Now we'll be talking about ice crystal process. The other name ice crystal process is called Bar Bargeron process because the Swedish meteorologist actually invented this process. That's why by his name it has been ice crystal or Bargeron process. So the ice crystal or the Bargeron process of rain forming is extremely important in the middle and high latitude regions where the clouds extend upward into the regions where the air temperature is well below the freezing point. Such clouds are called cold cloud. So if you look at in the left side, the typical cold cloud has formed over the Great Plain, where the cold part is well above the 0 degree isotherm. We know isotherm means that the same temperature line on the map. Suppose that we take an imaginary balloon flight up through the cumulonimbus cloud. So entering the cloud, we observe cloud droplets growing larger by the process described in the previous lecture. So as expected, only water droplets exist there, for the base of the cloud is warmer than 0 degree centigrade. Surprisingly, in the cold air just above the 0 degree isotherm level, almost all of the cloud droplets are still composed of liquid water, although it is like 0 degree isotherm. Water droplets existing at the temperature below the freezing point are referred to as supercooled droplets or supercooled water. Even at higher level, where the air temperature is minus 10 degrees centigrade, there is only one ice crystal for every million liquid droplets. So although the temperature is lower, still ice crystal didn't form. Near 5,500 meters above the ground, where the temperature became somewhere like minus 20 degrees centigrade, the ice crystal become more available, more in number, but still they are outnumbered by the water droplets. The distribution of ice crystal is not uniform, as the downdraft contain more ice than the updraft. Not until we reach an elevation of 7,600 meters, where the temperature drops below minus 40 degrees centigrade. Then we have only ice crystal at that level of atmosphere. The region of a cloud where only ice particle exist at 7,600 meters above, where the temperature below 40 degrees centigrade, we called it glaciated. So why are there so few ice crystals in the middle of the cloud, even though the temperature there are well below freezing? So laboratory study reveals that as this smaller amount of pure water, the lower temperature at which water freezes, given that the cloud droplets are extremely small, very tiny. It takes very, very low temperature to turn them into ice. So we learned that as the water droplet become bigger, it become ice crystal quickly than the very tiny droplets. Just as liquid cloud droplets form on condensation nuclei, ice crystal may form in sub-freezing air on a particles called ice nuclei. The number of ice-forming nuclei available in the atmosphere is small, especially at the temperature above minus 10 degrees centigrade. However, as temperature decreases, more particles become active, promote freezing with collision and coalescence. The water droplets with the opposite electrical charge meet together and become bigger and become droplets. And also, if the temperature becomes lower in the higher altitude, such as the point of 7,600 meter, way below the freezing point, then it's become ice crystal more and more.